Okay, and then go back and share this screen and read the message again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so good morning, happy Monday and all that good stuff. So a few things I want to talk about, and if I remember, I may forget some things and mention them later during today if I remember them. But first of all, some of you have not signed up into WebAssign yet. About a third of the class is still not registered for WebAssign. Now, if you ordered the textbook material from the bookstore like I asked you to, but it still hasn't come, what you can do temporarily, you can just go onto webassign.com, create a student's account, and once you've created it by using, let's see, you need to use an email and create a password, make sure you remember what the password is. Then you can use that student key code that I gave you in your syllabus, and that will get you into an account that is a temporary account that it's free for like, I don't know, 8 or 10 days. But then you still, if you haven't already, you still need to order the materials from the bookstore because that free trial will expire and then you'll be up a creek without a paddle. So order it if you haven't already. When it comes, convert it over to a paid account. All right. Let's see, what else did I want to say? I don't know, I forgot because I saw people just joining. But anyway, you need to do that. Oh, I know what else. The syllabus. If you haven't already, print out the syllabus, read it. It has the assignments for the entire quarter, what day they'll be assigned, what day they're due. And I want to talk a little bit about that. For instance, today on that syllabus, it says that we're going to cover section 6.1. And then it says it's due tomorrow by 11:59 p.m. Here is not what you should do. You should not wait until tomorrow at 10 p.m. and start the assignment and not finish it and then send me an email saying, I didn't have enough time, can I have an extension? That's not how it works. What you're supposed to do is this. Today's assignment you work on today. You should try and complete it today. If you have some questions about 6.1 that you're not able to figure out, then you email me and I'll either get back to you right away or when I can, or if you say, hey, Mr. Mayo, can you do the WebAssign problem from section 6.1, problem number 14, I'm having problems with it. Can you do that tomorrow in your Zoom lesson? And if you request that, then tomorrow during this regular time, I will go in and do that problem and it'll be posted on YouTube and all of that. Okay, so you got to do it the day it's assigned to be able to ask questions in time to get an answer before it's due. If you wait until tomorrow afternoon to start working on the assignment, and then you request some help, I may or may not get back to you tomorrow afternoon. So you need to do it the day it's assigned, not at the last minute, the day it's due. Okay, before I go on, oh, I know what else. I see that in the chat, people are already asking me questions. Oh, I see that. They said, yes, we can hear you. Good morning. Thank you for all that. I don't tend to look at the chat during the meetings. I've just got enough going on. So if you have a question, please go ahead and just, ask it. Okay. And I don't think we'll get people interrupting each other, hopefully. But anyway, let's do that. All right. So let's see here. Where's my mouse at? Yes, here we go. So today, as I mentioned, we're going to cover section 6.1. What we're looking at is we're going to learn eventually in chapter 6 a process to use to solve equations that are higher than first degree equations, second degree or third degree or fourth degree equations. So we're going to learn a process that allows us to solve higher degree equations. But there's a lot of steps involved in it. So when we finally get to almost the very end of chapter 6, we'll be solving second or third degree equations. But right now we're going to work on learning the tools that we'll use to do that. So let's go ahead and get started. Okay, now 12 is equal to 3 times 4. We say that 3 and 4 are factors of 12. Factors are numbers or quantities that you multiply together to get 12, okay? So if we factor something, we're breaking it down into quantities that are multiplied together to give you the final result, all right? Now, there's something called the greatest common factor. Let's say we have the numbers 10 and 15, and we want to determine the largest number that is a factor of 10 and is also a factor of 15. Now, as we get better at it, we can often just look at it and see it, but I'm just going to kind of start from the beginning. What we're going to do, we're going to take each of these numbers, the 10 and the 15, and we're going to break them down into prime factors, okay? So 10 is equal to 2 times 5. We say that 2 times 5 is the prime factorization of 10. So 2 and 5 are both primes. This is something you probably did a long time ago. Okay, the number 15, the prime factors are 3 and 5, 3 times 5. So 2 times 5 is the prime factorization of 10. 3 times 5 is the prime factorization of 15. Now, hopefully it's obvious to you that the common factor, in fact, the greatest common factor is 5. So the greatest common factor of 10 and 15 is 5. That's the largest number that is a factor of both 10 and 15. Are there any questions about that example? Okay, let's take a look at another one. Let's say I've got 16, 24, and 48, and I want to find the greatest common factor. Now, again, some of you might be able to go in and you can figure it out just by looking at it, but if you're not there yet, the thing to do is the prime factorization. 16 is 4 times 4, but 4s aren't primes. 4 times 4 is 2 times 2 times 2 times 2. That's the prime factorization of 16. 24 is 4 times 6, or 2 times 2 times 2 times 3. 48 is, let's see, 8 times 6, 2 times 4 times 2 times 3, 2 times 2 times 2 times 2 times 3. Okay, so again, this splits up to that. This splits up, let's see here, if we're going to draw the little lines, this goes here, this goes there, this goes there. Okay, so I've got the prime factorization of each of the original numbers. What is the greatest common factor? Well, 2 is a common factor, but so is a second 2, and so is a third 2. How about a fourth 2? No, there's no extra 2 in the 24, and there's no 3 in the 16. So the greatest common factor is 2 times 2 times 2, or 8. Okay. So the greatest common factor of 16, 24, and 48 is 8. Again, if you can just look at them and determine that, you don't have to go through all of this, but this is a way to get there if you need to. Any questions about this example? All right. Let's take the following. 9a and 21. We are to find the greatest common factor of each of these. Well, 9a would be 3 times 3 times a, and 21 would be 3 times 7. they have a 3 in common, and that's it. So the greatest common factor would be 3. Any questions on that example? Okay. If I'm going too fast, you need me to slow down, tell me. I'm not in a hurry. I'm not going anywhere. So let me know. And again, a reminder, this is being recorded. I'll upload it to my YouTube channel later today. So if there's something that you didn't get all written down and you want to come back later, it'll be there. All right. 18r, 27r cubed. 18 is 2 times 9. So we've got 2 times 9 times r, 2 times 3 times 3 times r. 27 is 3 times 9 times r cubed. 3 times 3 times 3 times r cubed would be r times r times r. So if we break it down into its smallest factors that are primes, let's see. They don't both have a 2 in common. They both have a 3 in common. They both have a second 3 in common, and they both have a single r in common. So the greatest common factor is 3 times r, which is 9r. Again, any questions there? All righty. Let's see here. How about this one? 15 c squared d to the 4th, 10 c squared d, 40 c cubed d cubed. So 15 would be 3 times 5, and then c squared, c times c, and d to the 4th power d times d times d times d. 10c squared d would be 2 times 5 times c times c times d. 40 is 8 times 5, or 2 times 2 times 2 times 5, and then times c times c times c times d times d times d. All right. So they don't all have 3s. They don't all have 2s, but they all have a 5. Okay. They all have a c. Oh, they all have 2 c's. They don't all have 3 c's. They all have a d. And that's all they've got. So the greatest common factor is 5c squared d. Now, this gets rather tedious, especially when we're taking things like d cubed or d to the 4th and writing d times d times d times d. Let's see if there's a pattern there. Okay, so the numbers, breaking it down into primes, we've got that. But the variables, if you take a look at c squared, and c cubed, we ended up with the smallest power of c that was up there as part of our greatest common factor, c squared. Okay, also, take a look at the d's. We ended up with the smallest power of d that's up there as our greatest common factor. So how could we do this problem a little more efficiently? Well, let's go back and let's do it again. Let's say we've got 15c squared d to the 4th, 10c squared d, 40c cubed d cubed. So I've got 3 times 5, 2 times 5, 2 times 2 times 2 times 5. So I've got 5. Now the c's, c squared, c cubed. So c squared is in each of them. D to the 4th, d to the cube, just d. Okay. So with the variable powers, it's going to be the lowest power of each variable that's up there because it's got to be common to all the different terms. Okay. All right. Now, how about this example? 2 times the quantity y minus 1, 5 times the quantity y minus 1. So 2 is a factor, y minus 1 is a factor. Just the y is not a factor of the whole thing because it's not being multiplied by everything else. Y minus 1 is a factor. Y minus 1 is a factor. So our greatest common factor here is the quantity y minus 1. Any questions about that? All right.
So, oh, wait, I have one.
Go ahead.
So this is, I'm just confused. Like, so when do you, so if the question is asking what's the greatest common factor, it's not asking you to go through the whole distributive thing, right?
Right, right. In fact, factoring is ultimately kind of the opposite process of, or the inverse process of distributing. Eventually we'll get to that, but yeah, so yeah, you wouldn't say, oh, this is 5y minus 5. Okay, that's true, but that's not what we're doing. We're kind of going the other direction, as you'll see though. But
Gotcha.
okay, sure. So let's take a look at another one that's kind of like that. A times b plus c and 3 times b plus c. So the greatest common factor is b plus c, very much like the previous example. All right. Now we're gonna move into past the shallow water into gradually to the deep end. So get your life jackets on. Here we go. This says factor out the greatest common factor. So we have 18x plus 24. Now, using a process like I was doing earlier, 18 is what? 2 times 9, 2 times 3 times 3. So 18x is 2 times 3 times 3 times x. 24 is 4 times 6, 2 times 2 times 2 times 3. So what do they have in common? They have a 2 in common and a 3 in common. So the greatest common factor is a 6, okay? But it doesn't say what is the greatest common factor. It says factor out the greatest common factor. So what I'm going to get down here is 6 times what's left. I've got 3x plus 4. So there's the takeout, which is the 6, and the leftovers, which is the 3x plus 4. Now, what I've just done was kind of undistributing. If I started with 6 times the quantity 3x plus 4, and I asked you to distribute the 6, you'd get 18x plus 24, okay? Which is kind of like what you were talking about a minute ago, Russ. But here we're going the other direction. Instead of multiplying the 6 into what's there, we're pulling it out of this. So it's called factoring. I think you could also call it undistributing if you wanted to. A little awkward, but it works. All right. Now, how do I know if I've done this step correctly? Well, 2 things. First of all, if I look at what's inside the parentheses, is there something I missed, something I could have taken out that I didn't? Okay, and it looks like there isn't. Secondly, if I multiply this back together, do I get what I started with? Okay, now, what I want to do is I'm going to go back and I'm going to do this problem again, but I'm going to do it wrong. Okay. Let's say that looking at it, I see that, oh, 18 and 24 are both even, so 2 is the greatest common factor. So I got 2 times, what, 9x plus 12, okay? Now, 2 times the quantity 9x plus 12 is equivalent to 18x plus 24, so this is a true statement, but I didn't take out the greatest common factor, okay? How do I know? Because if I look at what's left inside, oh, there's a 3 that's common to both of those. So I should have taken out a 2 and a 3, which means I should have taken out a 6. Okay, so you want to look at your leftovers. Is there something that you missed? Now, if you go back and do it, breaking it down all the way, prime factoring, it's going to be more obvious, but it's also more work. So you kind of have to decide for yourself, you know, what amount of work you want to go through. All right, let's take a look at this one. 33h to the 4th minus 22. So looking at the numbers 33 and 22, this is what, 3 times 11 times h to the 4th, and this is 2 times 11. So it seems to me that 11 is the greatest common factor. So if I'm going to factor out the greatest common factor, it's going to be 11 times 3h to the 4th minus 2. Any questions there? All right. Take a look at this one. 27a squared minus 9a plus 9. Okay, before we do this problem, I want to talk about one of, I think it's Grimm's fairy tales, Hansel and Gretel. Does anybody know the story of Hansel and Gretel? Okay, so yeah, so, and I'm not talking about Hansel and Gretel, the witch hunters or whatever that movie is, but you know, the old story, right? So the kids, they wander off into the woods, but they're, you know, they're thinking, oh, we might get lost. So let's leave a trail so we can get back, which was a good idea. But they left a trail of breadcrumbs, which was a bad idea because the birds came and ate the breadcrumbs and then they were lost, and well, you know, the rest of the story gets gory and all that. But the point is they had a good idea, and that is leave a trail so you can get back to where you came from. Now, what does that have to do with this problem? Okay, well, can you see that 9 is the greatest common factor? Everybody okay with that? So here. Now, this is wrong, but it is a typical mistake that people make. They think, well, 9 times 3a squared is 27a squared, and 9 times minus a is minus 9a, and plus 9, well, I've got 9 right there. But you need to be able to get back here, and if you distribute, you have to have a plus 1 there to be able to get back. You got to leave that trail, but not of breadcrumbs, okay? So going back to the beginning of the problem, we've got to have that plus 1. Without it, you can't get back, and then you end up in the oven, and you know, things aren't good. Okay. Let's see here. Let's take a look at this one. Now, the directions here say factor out -1 from each polynomial. So all he wants you to do is factor out a -1, okay? Well, if you factor out a -1, it's going to change the sign of every original term. So this is going to be a x plus 2y, because this is going to become positive and this is going to become positive because you're factoring out a -1, which is going to change the signs, okay? Any questions about that? And then somebody will always say, well, can you write it this way? Yes, you can, because there's an implied 1 there. So you could just put a negative sign if you wanted to, all right? Let's see here. Another one of those, -t squared minus 9t plus 1 would be -1 times t squared plus 9t minus 1, because again, you're changing the sign of all 3 terms. So this is going to become a -1 inside, because this would be -t squared minus 9t plus 1. Why are they having us do that? Because down the road a piece, we're going to want something like this, but we're going to want this to have a positive coefficient. So by factoring out a -1, then it makes it a +1 in front of it. to deal with. Okay, it's coming. So is Christmas, but we'll get there before Christmas, I promise. Okay. Now, it says factor each polynomial by factoring out the opposite of the greatest common factor. And what the book is doing, they're saying that a greatest common factor has to be positive. And that's fine if you want to think of it that way, but I think you could also consider a greatest common factor negative. So you could say factor out the opposite of a greatest common factor or factor out a negative greatest common factor. Well, so I'm going to take out a negative, what, 2a. Are you okay where I got the 2 from the 4 and the 6 and the a from the a squared and the a? So what's left over? Let's see. Negative 2a times what would be negative 4a squared? What, 2a, right? And then negative 2a times what? Times plus 3. So here I can move that over a little bit. Now, if I've done that correctly, multiplying it back together, I should get that. And there's nothing common here other than a 1. So in other words, rather than taking out 2a as the greatest common factor, they want you to take out a negative. Why? Because again, we're trying to get this leading term inside to have a positive number in front. Okay. All right. Now, I've got y times x plus 2 plus 3 times x plus 2. And the directions just say factor. Well, so far, all we've really looked at was taking out the greatest common factor. So the factors are y and x plus 2 or 3 and x plus 2. So the greatest or the greatest common factor would be what? X plus 2, right? But it didn't say identify the greatest common factor. It goes beyond that. It says factor. Okay. Well, if I take out an x plus 2, what do I have left? A y plus 3. If I take that and I multiplied it all out, I've got what? Y times x plus 2 and then 3 times x plus 2. So I've taken this and I've factored it. So I've written the entire original expression as one big product. A product is when you're multiplying things together. Okay. Any questions about this example? All right, let's take a look at another one. Let's say I've got m times the quantity p minus q minus 5 times the quantity p minus q. Well, I've got m times p minus q minus 5 times p minus q. So the greatest common factor is p minus q. But what do I have left? I have m, oops, sad looking m minus 5 times p minus q. And it's important that I've got the parentheses there, because if I wrote it like this, that would just be m times p minus q. That would get us, oops, that would, that would get us this expression, but I need to group it so that I'm also taking the p minus q times minus 5. Okay. Hopefully that didn't confuse you with all the stuff that disappeared there. Okay, how about this? AB times c minus 7 minus 12 times c minus 7. So I'm going to have c minus 7 times AB minus 12. So there's the takeout and there's the leftovers. Okay. Questions about that one?
Yeah, so how do you know that the AB is joined and not independent of each other?
In other words, with the minus 12 or with this?
At the top where it's AB, yeah, right there. So how how do you know those aren't two individual variables? Like, what's the indication that those are two independent?
Okay, they are individual variables, but they're being multiplied together.
Gotcha. That makes sense.
Okay, for instance, this wouldn't be efficient, but you could also write it like this. You could say, oh, the 2 times 6 is actually one product, but we can take that and say, well, it's 12. Well, here, I suppose we could call it ab, but because they're not, we can't simplify it further. They have to stay separate, even though they're multiplied.
Gotcha.
Okay, keep asking. Okay, all right, now, how about this one? 2x plus 2y plus ax plus ay. Suddenly we've got 4 terms, okay? 2x, 2y, ax, and ay. 4 terms. The directions still say factor. They actually say factor by what is called grouping. And I'm going to talk about that here in a minute. If I look at all 4 terms, the greatest common factor of all of them is really just a 1. They don't have a 2 in common or an a or an x or a y in common, okay? And taking out a 1 isn't going to do anything at this stage. So what I'm going to do is I'm going to do what's called factor by grouping. And in this example, and in fact, in the examples that we deal with in this textbook, we're going to split it up into 2 groups of 2. So we're going to group it into 2 groups of 2. Okay? And we're going to treat them separately. So take a look at 2x plus 2y. The greatest common factor of both of those terms is a 2, and I'd have an x plus y left over. Do you see how I got from there to there? Okay, now let's take a look at the second group, ax plus ay. The greatest common factor there is an a, and the leftovers are, again, x plus y. Now, in the original problem, this was 2x plus 2y plus ax plus ay. So I need to bring that plus sign down to continue to make it equivalent to what was up above. Okay, so this statement right here is equivalent to the original statement. But now this problem looks like some of the ones we just dealt with earlier. What's the greatest common factor of these 2 groups? Well, it's x plus y, and the leftovers are 2 plus a. So we've taken these 4 terms, split it up into 2 groups of 2, factored each group, and then our result is one big product. Okay? You all right with that? Okay. Now, you might be saying, well, that doesn't look at all like the original. How do you know it's true? Recall back in beginning algebra or math 85, or maybe it was high school algebra 1, we did something called foiling. If we were going to take this and multiply it out, we'd get 2x plus ax plus 2y plus ay. And if you look at those 4 terms, even though their order is changed, they are the same 4 terms. Okay, recall that addition's commutative, so we could move these 2 terms around if we wanted to. Okay, so what I've got here is equivalent to what I started with, but it's factored, written as one big product. This is factoring by grouping. Okay, let's take a look at another example.
So
yes,
where it's written as ax, since it's x times y, or x times a, sorry.
Talking about here?
No.
Which
Well,
one?
kind of. Yeah, so I'm just, does it matter if you put the a or the x first?
Oh, like here?
Yeah.
Okay, technically, those are equal. because multiplication is commutative. So a times x equals x times a. But in a given expression, a given term, we tend to put the variables in alphabetical order. And the reason for that is so if you're combining like terms, it makes it easier to identify. For instance, let's say I had 2ax plus xa3. Okay. Are those like terms? Well, they don't look the same, but if I wrote them both like this, you'd see, oh, yeah, that's 5 times ax. Whereas here it's not as obvious.
Right.
So yes, it's legal, but it's better to put them alphabetically. Okay. Not all things that are legal are necessarily wise,
Right.
as some of us have discovered. Okay. Let's see here. 6a cubed minus a squared plus 18a minus 3. Again, it says factor by grouping. Okay. Now, there are 4 terms. 3 of them have a, but the 4th one doesn't have a. So a is not a greatest common factor. The 2nd term has a coefficient of a 1. So there's really no number. There's really nothing we can take out of all 4 of them. So we're going to group them in groups of 2. The greatest common factor of the first 2 terms is 1a squared, or just a squared. The leftovers, well, let's see, a squared times 6a, a squared times minus 1. So the leftovers would be 6a minus 1. You okay with that? All right. Plus, what's the greatest common factor over here? Looks like it's a 3. And the leftovers are 6a minus 1. But now if I look at this example, that is a common factor of both of the expressions. So I've got 6a minus 1, a squared plus 3. Now, this doesn't always work. These problems are set up so that they're going to work, okay? Because if these 2 quantities in parentheses weren't identical, we couldn't finish the problem like they want us to, okay? So if you're thinking, oh, I can just take 4 terms out of nowhere and write them and do this, no, you can't. It's a setup. You're being set up here, but it's to show you a process that we're going to be using, and where we're going to use it later, it will always work. All right. Now, let's take a look at, let's see here, xy plus 3y squared plus x plus 3y. Well, not every term has a y, and not every term has an x, and not every term has a 3. So again, I'm going to use factoring by grouping, which is what the directions say to do. The greatest common factor of the first 2 terms is y, and the leftovers are x plus 3y. Is everybody okay where I got the x and the plus 3y? All right. Now, the greatest common factor of x and plus 3y is just a 1. Okay, now, I could do this, and that is a true statement. There's nothing wrong with that statement, but I'm going to go ahead and put the 1 out there to remind me that I need to have a trail to get back, because the next step is going to be x plus 3y times y plus 1. So if I leave it off of there, then I've got to still remember I need it down here. So it's best to put it there. Okay. So then you've got that comes out and that's left over. All right. Let's see here. Rx plus Sx minus Ry minus Sy. Greatest common factor of all four terms is just a 1. So we're going to use factoring by grouping. The greatest common factor of the first two terms is x. And my leftovers are R plus S. Now, my next two terms, the greatest common factor is a y, or is it a negative y? Because see, I've got that negative there in here, okay? So do I take out a y or do I take out a negative y? Well, let's go back for a minute. Let's see. This was a problem I did earlier. And remember, I made a deal about saying these, oops, I've got the eraser on. These two have to match to go to the next step, okay? These two have to match to go to the next step. So that means that these two have to match to go to the next step. So inside, I need it to be R plus S. If I put negative R minus S, it won't match this one. So what do I need to take out of here? A y or a minus y? I need to take out a minus y in order to get this to match with that. Does that make sense? Maybe. So now I've got R plus S, X minus Y. Okay, now take a look at this example. 9p minus 9q minus mp plus mq. The greatest common factor of all four terms is just a 1. So we're going to use factoring by grouping. Okay. The greatest common factor of the first two terms is 9. And I've got a p minus q left over. Now, here's my advice. Don't look up, look over. What do I mean by that? Don't look up here, look over there and clone the results, okay? Because I need them to match for this to work. So rather than looking up here to figure out what to do, I've got to have a match, so make it so. Well, now, what would I have out here to make it work? Well, would it be an M? No, it'd have to be a minus M, so that I'd get minus MP, and then minus times minus would be plus MQ. So by looking over and matching it, I'm going to know whether to take out a positive M or a negative M. And then I'm going to get P minus Q, 9 minus M. Hopefully my Q's and 9s don't look the same. 9s are Q's that have lost their tails. Or I don't know, whatever. Anyway, polywogs turning into frogs. It's a small biology lesson there, very small. All right, you getting the hang of it there? Maybe? We'll find out. Okay, now, let's see here. How we do on time? We've got time. 5m cubed plus 6 plus 5m squared plus 6m. Okay. Well, the greatest common factor of all four terms is 1. So let's use factoring by grouping. The greatest common factor of the first two terms is just a 1. So if we do this, we're just going to get that, which means I have to match that over here. And that's not gonna work. Huh. So what I'm going to have to do is this. I'm going to take my original polynomial, those 4 terms, and I'm going to write it in descending powers of the variable, which is also known as standard form. So 5m cubed plus 5m squared plus 6m plus 6. And now let's see if I can attack it and get what I want to have happen. So my point is sometimes what you're given isn't going to work. You got to rearrange things and then maybe it will work. So now we're going to split it up. Greatest common factor is going to be 5m squared. So I'm going to have m plus 1. All right, there's the breadcrumbs. So over here, I'm going to have m plus 1. Don't look up, look over, clone it. What's going to be out here is going to be a plus 6. So I get plus 6m plus 6. Okay. You see how I got there? So now I've got m plus 1, 5m squared plus 6. Okay. Now, let's take a look at this one. How we do? We got time for another one. Ax cubed minus 2ax squared plus 5ax minus 10a. Oh, I don't need to factor by grouping yet. There is a greatest common factor. What is it? Give me a good Canadian answer.
X.
No, a Canadian answer. There's no X in the last term. What would the Canadians say?
A.
There you go. Thank you. So we'll take out an A. We get x cubed minus 2x squared plus 5x minus 10. A. Okay, the fawns. A. So we took out the greatest common factor. Now, what's left over in the parentheses, though, there's 4 terms. We're still going to try factoring by grouping. So I'm going to have an A, and then I'm going to use brackets to emphasize as opposed to the parentheses. Okay. So my greatest common factor here would be x squared, and I'm going to have an x minus 2. Don't look up, look over. So I got to have an x minus 2 and then a plus 5. So this came from here. This came from here. This came from here. Okay. So now I've got that A. I'm going to take out the greatest common factor and then the leftovers x squared plus 5. So that whole product is factored. So you always want to look for a greatest common factor first. And then if there is one, take it out, go on from there with the leftovers. If there isn't, then just go on from there. Question? Oh, okay. You turned your mic on, so I thought you were going to say. That's fine, not a problem. Just thought maybe you had something there. Okay, let's see here. At the end of a section, there's in the book, there's something that says try it yourself, where they kind of mix things up a little bit. So let's take this one first of all. Okay. So the greatest common factor would be 14 plus r, and the leftovers would be h squared plus 5. Now, a question people will ask is it okay if I wrote it this way instead? Let me ask you this. Is 3 times 2 equal to 2 times 3? Yes. Multiplication is commutative. So these 2 factors, the orders could be switched, and we still get the same result. Okay. What I tend to do, I always tend to take whatever I'm going to take out and put it in the front and the leftovers at the rear. But other people may do it a different way. Okay. All right. Let's see here. How about this one? 39r cubed plus 26r squared. It says factor. Well, this isn't factoring by grouping because typically that has 4 terms. But is there a greatest common factor? Well, I can see they both have r's, but 39, 26. Well, 39 is what? 3 times 13. And 26 is 2 times 13. Oh, so 13r squared. And then what's left over? Let's see. 3r plus 2, like that. So that kind of takes us back to the beginning stuff in this section. All right. So just a reminder, I'll be back at 1:15 with an office hour. It's a different Zoom ID number if you want to come in there. Okay. If you come up with some questions and you want me to do them in tomorrow morning Zoom, email me telling me so. Otherwise, if you can't make the Zoom meeting this afternoon, but you get some questions, email me and I'll get to you when I can. I saw there's a lot of emails from people that haven't registered yet, so I will be dealing with those this afternoon. So if you're one of those people, I should be getting back to you sometime later today. I'm going to go ahead and stop the recording. And so I